Okay, geometry work. So for this I will speak more. Classify each triangle by each angles and sides. Base your decision on the actual lengths of the sides and the measures of the angles. So I don't have a protractor at hand. I wouldn't be of much use anyway. So this one, I would say that it's an obtuse scalene. Due to the obtuse angle here, and because the sides don't appear to be equal, that may be equal to that, in which case it may be an obtuse isosceles. I could be wrong. This one here, though, definitely an obtuse scalene. In fact, I'm willing to bet that this is isosceles. I don't have a ruler which I'm willing to press up against my screen, but we'll see. Okay, I'm correct. And I would indicate that it's an isosceles by 2 small marks like that. This appears to be a right isosceles. Followed by an acute isosceles. It's acute as the apex angle. We'll call it that for now. The apex angle is acute. And we check. And that's correct. This appears to simply be a right triangle or right angled triangle. And this appears to be an equilateral triangle. Which equivalently is an equiangular triangle. And we check, and that's nearly correct, but it's better to call this a right scalene. Give the angle information, followed by the side information. Obtuse, right, acute. See? Now, classify each triangle by angles and sides. So this is just an equilateral. This here is, well, I would say an acute scalene. And we check, and that's correct. A right scalene triangle, followed by an obtuse isosceles triangle due to the these two sides being congruent. An obtuse isosceles. And we check, and that's correct. Followed by an acute isosceles. And a right isosceles. Checking. Correct. Next, classify each triangle by each angles and sides. Equal sides and equal angles, if any, are indicated in the diagram. So this would be an obtuse scalene. an acute isosceles, correct, a right scalene, an acute scalene, an obtuse isosceles, a right isosceles, okay, an acute isosceles. Draw the base, the apex, and failing drawing it well, just indicate on it like that. A right scalene, that will do. It's visually obvious that that's scalene, but we can indicate like so, if we wish. A right isosceles, like so. A right equilateral, not possible. An acute scalene, no. Better. An obtuse scalene, a right obtuse, impossible. If one angle is right, the other two have to sum to 90, and therefore one of the others must exceed 90 to be obtuse, which is impossible. And finally, an equilateral. That's all good. Yeah, that's all fine. Next. Oh. It hasn't been streaming. Oh well. Just one is missing. Now, for angles in a triangle. Find the measure of each angle indicated. The crucial theorem here is that the interior angles of a triangle sum to 180 degrees. And so here, these sum to 122 degrees. Take that from 180, and we have 58 degrees. And this must be 50 degrees. $30, 45 degrees. Angles on a straight line sum to 180 degrees, i.e. they supplement one another. But, beg your pardon, so 180 take away 137 is 43. 43 at 102 is 145. Take that from 180 and we have 35. And so the angle here must be 180 minus 35, which is 145 degrees. These are vertically opposite angles, and so this must be 35 degrees. This angle here complements that angle there, and so it must be 55 degrees. And this angle here supplements the adjacent angle to it, as they are angles upon a straight line. So 180 take 55 is 125 degrees. This angle here supplements the sum of the other two, so it must be 130 degrees. And this is vertically opposite, so this must be 130 degrees as well, as it's congruent. This adjacent angle to the 155 supplements it, so it must be 25 degrees. Therefore, this angle here must be 95 degrees, and so this angle here must be 85 degrees. It's tempting to think that these alternate each other, but there's no indication of the parallelism of these two line segments here. And so, thinking of the interior angles of a triangle, that must be 120 degrees. This is vertically opposite, so it must be 120 as well. And 120 plus 39 is 159, which, when subtracted from 180, gives 21. All right, so this angle here must be 55 degrees. Added to 50 gives 105. Taken from 180 gives 75. 75 at 35 gives 110, which leaves 70 degrees left. 84 at 36 is 120, so this must be 60. And as it partitions a right angle, this angle must complement it. And so it must be 30 degrees. 86 at 30 is 116. Take that away from 180, and the result is 64. This angle here, well, 35 at 23 gives 58. Take that from 180, and we have 122. This is vertically opposite, and so it must be 122 as well. Add that to 27, we get 149. Take that away from 180, and we get 31 degrees. Angles on a straight line. So this angles on a straight line. So this here must be 65 degrees, and this down here must be 30 degrees, and 30 and 90 makes 120, so this must be 60 degrees. This being adjacent to it on a straight line must be 25 degrees. 25 at 60 is 85. Take that from 180, and that's 95 degrees. And so this must be 85 degrees. "20 and 35 is 55. Take that from 180, and that's 125 degrees. This is vertically opposite. So it must be 125 degrees as well. This is adjacent to 156 upon a straight line. So it must be 24 degrees. 24 at 125 is 149. Take that from 180, and that's 31 degrees. This is 45 degrees here, and this is vertically opposite, so it's 45 degrees as well. 45 at 60 is 105. Take that from 180, and that's 75 degrees. 75 at 68 is 143. Take that from 180, and that's 37. 100 at 37 is 137. Take that from 180, and you get 43 degrees. And take that from 180, and you get 137 degrees. This is vertically opposite, so it must be 75 degrees. This angle here must be. And likewise for this one. 45 at 75 is 120, so this angle in the corner must be 60. 60 plus 79 is 139. Take that from 180, and you get 41 degrees. 41 at 68 is 109. Take that from 180, and you get 71 degrees. Take that from 180, and you get back to 109 degrees. Now solve for x. 55 at 54 is 109. Take that from 180, and you get 71. So x at 74 equals 71. So x must be -3. 70 add 60 is 130. Take that from 180 and you get 50. 8x add 2 equals 50. So 8x is 48. So x is 6. $64 add 27 is 91. Take that from 180 and that's 89. Take that from 180 again and you get back to 91. And so 97 add x equals 91. So x must be -6. Vertically opposite angle here of 80 degrees. A vertically opposite angle here of 60 degrees. 80 add 60 is 140. Take that from 180 and you get 40. So x add 51 is 40. So x must be -9. And now to find the missing measure of the angle A. $59 add 51 is 110. Add 84 is 194. 194 add 2x equals 180. So x must be -7. Angle A is, the measure of angle A is x plus 51. So 51 minus 7, which is 44 degrees. $37 plus 67 is 104. 104 plus 90 is 194. So we get a very similar problem here. X is -7 and angle A is x plus 37. So angle A, the measure of angle A rather, must be 30 degrees. This angle here is vertically opposite, so it must be 8x plus 4. This angle, this interior angle of the triangle supplements this one, so it must be 50 degrees. And 50 plus 4 is 54, take 6 is 48. 48 plus 11x is 180. 180 take 48 is 132. 132 divided by 11 is 12. A is 3x take 6, so 3 times 12 take away 6 is 24. This angle here is vertically opposite, so it must be 4x plus 17. Now, 23 plus 17 is 40, plus 80 is 120. Add on the 5x. And we get this. So 5x must equal 60, so x must equal 12. And so angle A, the measure of angle A, must be 35 degrees. And we check everything. We check everything. No. That's wrong. Correct it. Okay, that must be 45. And so that must be 35. Okay. Wrong. Correct it. Okay. Okay, now it seems obvious. And this is another error, so correct it. I hate making errors. But it's (11x) take 2. 11x plus 48. That's foolish. But it was fixed. Hardly any mistakes. Not many, but too many. Okay. Now comes the exterior angle theorem. Exterior angle theorem. And the challenge is to stop making mistakes. Okay. Right, well, the exterior angle theorem makes explicit what I already believe. This exterior angle here is the sum of these two interior angles here. Similarly, 11x at 2 equals 5x plus 68. So 6x equals 66. So x must be 11. (45) at 8x must equal 18x at 5. So 40 must equal 10x. So x must equal 4. (12x take 4 must equal 10x at 20. So 2x must equal 16. No, wrong. So 2x must equal 24. So x must equal 12. 120 must equal 37x plus 9. So 111 must equal 37x. So x must equal 3. (20x plus 5 must equal 9x plus 38. So 11x must equal 33. So x must equal 3. Find the measures of the angles indicated. Okay, so 11x plus 8 equals 140. So x is equal to 12. So the measure of angle S is 3 times 12 plus 4, so 40 degrees. Next up, 5x plus 82 must equal 14x plus 1. So 81 must equal 9x. So x must equal 9. But we must find the measure of angle H. So that is 5 times 9, which is 45, take away 7, which is 38. Now, they say find the measure of angle FAB, and they actually get that incorrect, because that's actually this reflex angle if you go around counterclockwise, but must accept it how they do it. So, we know that 3x plus 57 must equal 13x take 3. So 10x must equal 60. So x must equal 6. So the measure of angle FAB in their universe, okay, is 13 times 6, which is 78. Take away 3, which is 75. Find the measure of angle YDC. Okay, so 6x plus 86 must equal 15x plus 5 by the exterior angle theorem. So 9x equals 81. So x equals 9. And so the measure of angle YDC, which again is clockwise, and I don't like that. The measure of angle YDC is 15 times 9, which is 135, plus 5, which is 140 degrees. And that completes it. So let's see if I was able to be accurate this time. Okay, 70, 65, 120, 105, 95, 30, 86, 130, 12, okay, doing good so far. 11, 4, 12, 3, okay, 3, all right. 40, 38, 75, 140. Yes. All accurate and correct. And that concludes my work for now. Be well.